Hey everybody, welcome to a short video series on the first-person body and body awareness features that were recently added to NeoFPS. In this video, we're going to be taking a look at the full body character. So this character, as you can see in the viewport here, is one that has the entire body as a single kind of unit. Like the arms are built into the body itself, the head, all of that. Now to demo this, we have a fairly simple setup. There's just a camera that is parented in the hierarchy of the character. So it follows it around and gives us 3/4 view. It's constrained to the top left. And then I've used the culling mask to cull out the different meshes. So for example, in the viewport in the top left, where you look at the body, you can see this is culled so that it shows a skinned mesh that covers the entire body. Whereas in the first person view, the culling shows only the body minus the head, and then has a separate mesh that's called, that shows, which is a shadow caster only for the head. Now the reason for this is that even though you might think you can put the camera inside the head geo and have it facing outwards and it would be fine, you will find that any kind of detailed mesh for a head will kind of show up little bits of triangles here and there. And also in deferred rendering, you will get things like shadows and post-processing will be affected by the inside-out mesh that your camera's inside of. So instead, we have this separate shadowcaster only head. And in fact, this is one of the big advantages of the full body character, is that we can do character shadows that all sync up and match up nicely. Normally, in the regular characters, the shadow casting will be disabled for the weapon and the arms, just because it will be floating around when you look at the ground otherwise. For the legs and torso version, there are ways around this, but it is complicated and it does require you to have two sets of animations, like a full body weapon animations and regular weapon animations. So yeah, why would you want the full body character one like this? So apart from those advantages, it has a lot more physicality than the regular FPS. This is the kind of controller, this is the kind of setup that you would see in something like a milsim type FPS. It's also kind of the basis of what you will get for the multiplayer, for looking at remote characters. Obviously that's not done yet, but this is kind of the foundation of what will be used for that. Why wouldn't you want it? Well, most FPS, stylistically, what you tend to get is the weapon and the arms and everything like that are framed to the camera, to the viewport. It kind of gives the artists and the animators and everything much more control over how the weapon is presented. Whereas here, the weapon is locked into your shoulder. As you can see it moving around as the character kind of moves around and breathes and everything like that. It's very tricky to get full body weapon animations that look good in first person, or look nearly as good as you will get from ones that are specifically built to fit within a camera frame. Things like reloads and things like that. It's all of the flourishes will be out of view and things like that. So the main reason you might not want it is stylistic. There's also things like syncing the weapon aim to the pitch and yaw. So here, for example, when we're looking up, you can see that the weapon is kind of now very differently placed to when we were looking straight forwards. And as we look down, same kind of thing, the camera pulls back and whatever. So now this might not be something that you want to happen. Again, like I said, you have much more control if the camera is framed, if the weapon is framed to the camera. But assuming you don't want this, let's have a look at how this is done. So I'm going to take a look at the template prefab here. This can be found in samples, single player, scenes, feature demos, first person body, and then the template subfolder. And it's this first person body full character template here. And the reason that I'm looking at the template and not one of the Kobold ones is because those are variant prefabs and everything in this list comes highlighted blue and just it's a lot harder to read. Okay, so what have we got? So if you've been looking at the other characters and you're comparing them to this one, then one of the first things that you might spot looking through the hierarchy here is this yaw transform. So one of the things that makes it a little bit complicated to add a body to a first-person controller in Unity is that it actually runs on two separate time steps. You have your physics, which runs on a fixed time step, which by default is 50 frames per second. And you have the variable time step, which is used for rendering and a good chunk of the game logic. and that one is as fast as your computer can render frames. So what you would find if you were to simply parent the character mesh to the root of your character is that that character mesh is then going to be moving around on the physics time step. So it's going to be moving around at this fixed frame rate. And the way that I've got the camera set up gives you full responsiveness based on your render frame rate. So as you're looking around, you're going to find that your body is turning at a different rate to your mouse and your camera. So you're going to suddenly see a lot of jitter. So the way that we get around this in the first-person body is by adding a new transform underneath the root here called yaw. And this is what is controlled by your mouse movement for the yaw rotation. Pitch rotation is handled separately, but essentially this yaw transform here will be rotated on the variable frame rate, and then every fixed frame, the character will rotate to match that. And then we parent our body models and animator and everything like that underneath this yaw transform here. This also enables us to add what's called the steering system, which allows you to turn the body at a different rate to your camera aim as well. So for example, you can quickly look left, your camera will instantly do that, but then your body will turn over time towards that as you're moving. That isn't something that's specifically required for these first-person body characters. It's also used in the demo facility character, for example. It just adds a nice bit of extra physicality and inertia to your movement. So, as I was saying, underneath the yaw transform, we have this object here, which is the first-person body object, essentially the prefab from the FBX that was imported with the skeleton, the animations, and the character meshes. So if we expand this out, then underneath this we've got a skeleton root here. So this is all of the bones that make up the skeleton. And then we have individual meshes here. Now there's a few of them attached to this character. And the reason for that is that we have various different view options. So for example, if I just close these ones here, hide them away. So first up we have this main character third person. You're not going to use this a lot of the time, but in the demo where we have the viewport in the top left that shows a third-person view of you walking around, this is the one that's being shown then. So this is on the character external layer, and then the camera, the follow camera, which is actually this object right here, so underneath the upper body root, we have an object called follow cam, which is just a parented object, and then we have this camera actually attached to it. And the culling mask on here is called so that it doesn't show character first person and it does show character external. Looking at some of the other options, we have the character first person full. So this is similar. It has the arms built into the body and it's just missing a head for where the camera should sit. This is the one that we use in this character for this full body character. We also have a head object here, which is invisible, but it acts as a shadow caster. And the way that it does this is using the skin mesh renderer here. There is this section called lighting and cast shadows. By default, I think this is just switched it on. But if you switch it to shadows only, then it essentially removes all of the rendering aspect of the character and it just writes to the different buffers that are required for shadow casting. A few other tweaks like receive shadows switched off. I think it forces that when this is set to shadows only, and switching off some of the other extra features as well. And then layer-wise, this is on the character first-person layer, same for this one here, and same for the other two. We can show you those just briefly. So we have first-person arms. This is potential for use in split rig characters. And we have a first-person body with no arms attached. This is used in the legs and torso only demo. Okay, so with the render meshes reset, let's have a quick look at the skeleton itself. So this character, if we can see the original FBX here, is brought in as a humanoid rig. If you want to retarget animations from other animation packs to work with your character, then you need to use a humanoid rig. Equally, the IK features that are built into Unity require you to use a humanoid rig as well. So for anything full character related, that's generally the best way to go. And that means that you have a kind of preset skeletal layout. And I've added a few things to this just to add some extra functionality. So first up, on a number of the bones, I've added these damage colliders. So these are set with the layer as character physics, just parented to the individual bones. They have a collider attached. Shape is just dependent on what fits the character best. And then they have a basic damage handler with a damage multiplier and a little flag to say is this critical damage or not. And this detects damage from gunshots, explosions, melee, things like that, and feeds it up to a health manager on the root of the character. Underneath that we have the simple surface with the surface set to flesh. So this handles the visual aspect and the audio aspect of damage and impacts and things like that. And we have a character impact handler with various force kind of settings here. So this will take things like a gunshot's force and pass it to the character controller to push you back, for example, things like that. We also have a few of these seeker target objects kind of dotted around in the hierarchy. These are used by my cameras and turrets. They're just an object that they can detect built in. So this is a lower body one, there's another for the head, another for the torso. Most AI won't use these out of the box, like you might want something similar in your hierarchy, depending on that. Mine are very simplistic and they just raycast against these, and if they don't hit anything other than this object, then they can see the character. Elsewhere in the hierarchy, we have, under here, so under spine 03, which is the top of the spine here, we have an object called item matcher. This is a proxy or a kind of socket object, which is where the weapons and things like that will be positioned. They won't actually be parented to this object or anything like that. Instead, they're parented to this item root object here, and this will be positioned each frame to match this. So as the animation moves the character body around, the position of the item root will match, but the rotation will be based on your aim direction, because you don't want the guns kind of spinning off as your character does all kinds of crazy moves. You want it fixed to the camera. We also have another one of these kind of proxy objects under the head, and this one is the camera proxy. So this is just positioned where the camera would be for this character. Z forwards, Y up, and so on. So that's it for the changes to the hierarchy of this character. Let's now have a look at the different components that we'll find that have changed to add this kind of first-person body functionality. So first up, let's have a look at the root of the character. And if we scroll down, we have the motion controller. And this has a few parameters here to do with the body animator and the upper body and the height. This error here is just because the character doesn't have an animator controller assigned to it here. If we were to assign one from, for example, the templates one here, we could drag in the template animator, drop that in, and go back to the root, and we'll find that that error has disappeared because it has a float parameter with that name in the animator controller. So, what's different here compared to a normal character? First up, the most obvious one is that we have a body animator because we've got a body. So this is just pointing at the animator here. And then we have this upper body root and upper body target. So in a regular NeoFPS character, so not one of the ones with a first-person body, the way that your character's height is changed is by moving this upper body root up and down. So this is essentially an object here that has a large number of the systems of the character underneath it. So it has the aimer, so this is actually serves a secondary purpose as the aim yaw, the camera yaw. It has a transform that's used as a pitch here. It has spring animations for the upper body. It has the camera itself, and it has the item root that the weapons are. parented to. And what normally happens is in the motion graph, or via the API, when you set the character's target height, the way that Neo does this is it moves this transform down to the new kind of target eye level, and then when it hits that, it resizes the character capsule. When you set the character height to stand up again, then it will go the other way around. It will resize the capsule up, and then it will move this object, and then it's completed when this object hits the new target height level. In a first-person body character, the eye level and things like that are tied to the character's head. If you remember that camera proxy object in the character's skeleton hierarchy here. So essentially the way that this works instead is when you set the target height for the character, it blends from the current height to that, and then sends the value as a float parameter to your animator controller. In this case, it's looking for a float parameter called character height. And then the character animations use a blend tree to blend from crouch to stand based on that value. The upper body root is then matched in position each frame to an object in the hierarchy of the character. So in this case, it's not actually the camera proxy, it's the item matcher here. And then the camera is constrained to that camera proxy separately. And the reason for this, you could go the other way around and match the upper body to the camera, and then constrain the item root object to something else within the character hierarchy. But we also want to do things like aiming down sights where we want different camera effects. So it's easier to switch in and out constraints for the camera object and then just keep this one fixed for things like weapons and stuff like that. So that's the motion controller. We also have the aim controller here. As I mentioned before, we have this new yaw transform. So in a more simplistic character, you might not have both of these set. If you don't, then essentially on start, it will copy this value across to the aim yaw. Essentially, when you move your mouse or your gamepad analog, it will rotate this aim yaw transform here, and then the yaw transform will be rotated separately to match that. So we have here this steering rate. This is the rate at which the yaw transform turns to match the aim yaw transform. If it's set to 1, then this is instantaneous, and essentially they're anchored together. If it's set to 0, then essentially the yaw transform will not turn towards the aim yaw. You'll have to do that manually yourself through the API, for example, or through various motion graph behaviors. The 0.25 second here is actually fairly low. It does mean that there's a fairly slow steering, and it was set like that just to exaggerate the effect in the demos here. You might want it a little bit higher yourself, but it's something to just experiment with the different values of. And essentially, those are the only changes from a standard NeoFPS character. So let's have a look at some of the other changes that we have just in this upper body hierarchy here. So most of this is quite similar. There's just one major change compared to the standards, which is adding in this camera constraints object here. As you remember, I mentioned that the upper body root will be matched to the item matcher here in the character's skeleton. We want the camera to match to this camera proxy here. And the way that we do this is with this first-person camera transform constraints. So this by default is set to constrain to this object here. And it's set to constrain with a strength of 1 for position and 0 with rotation. Then it has a little bit of damping because you tend to get compression artifacts that mean that animations, especially full body animations, can be a little bit jittery. So as you're running around, you don't want the camera like stepping and skipping all over the place. You want to add a little bit of smoothing to that. The other benefit of this camera transform constraint system is that we can add constraints to it after the fact. So for example, with the weapons, whereas as standard you would use something like a weapon move aimer, which moves the weapon to align it to the camera. In this case, the camera moves separately to the hierarchy of the weapons. So that wouldn't necessarily work. You'd find that the head would bob around too much and aiming down sights. It would be entirely dependent on your character animations. So instead, we can use a different aimer module on the firearms, which adds a camera constraint here, and then constrains the position rotation of the camera to match it to the weapon and align it to its optics. So that's that. Let's have a look at the components on the actual character model itself. So first up, we have the animator. So if you remember, I added in this template animator controller here to get rid of the error on the root. Normally on the template character, this is empty. There is an animator controller for the Kobold character, which is assigned in its variant prefab. Some people have mentioned that they've had issues going through the import process where the Kobold animator controller kind of lost references to the individual animation clips. So I have added a set of stub animations and an animator override controller, which can be used to tie those and override those with your character ones or the Kobold ones and things like that. And then that would be dropped in here instead. One important setting on here is this culling mode. So the way that the culling works is by disabling the animations when you're not looking at a character, for example. And in the case of the first-person character, where the body is attached to your own camera, that means that looking up and all of a sudden your character would stop animating because you're not seeing any part of it, which means that your head would stop moving, the bob and all of that, and the root motion might stop as well. So all of a sudden, first-person character would just instantly stop until you look down and saw your own body again. So we need to keep this set to always animate, which means that it doesn't matter where you're looking, it is always going to update. Underneath that, we have a component here called first-person body. This handles the foot IK as you're walking over, say, like steps and different ramps and things like that. It will match your feet position and tilt to match the ground. If you're standing on a steep slope, like a large slope, then it will actually also shift the body downwards so that you're not overextending the back leg. And then that has a little bit of damping as well. I think that's the IK offset damping there, and that's the maximum offset for it to do that with. And then we have the grounding cast distance, so how far to check below the kind of the virtual ground plane that the character was animated to see if you're hitting ground and to getting that offset for your feet. Below this, we have options to send your aim offset to the character's animator controller. So this ties into that steering system. So as you're looking up and down, or as you're looking left and right, and your head and your camera is rotated differently to your body, the difference there will be sent to these parameters in the animator controller. You can then use that in your blend trees and things like that to tilt the character's spine and twist it and various things like that. However, we actually have a procedural system that handles that for us, which I much prefer. It's an option for you to use if you really want to. I know that some animation packs come with those blends built in. Aside from the first-person body, we have the first-person character arms. So this handles the arm IK, so matching your hands to your character's weapon. So say the weapon has animated hand kind of proxies in there, it would snap your full body hands to match with those and then bend the fingers to match and things like that. We'll take a look at that a little bit later on. The root transform property here is one that we don't need for this character type. This is for the split rig, where we want to actually move the whole body of the character to snap it to the weapon. What you'll see if we were to grab just a random transform and chuck it in there is we'll get this little info box saying the transform above will be repositioned and rotated every frame to match the weapon view model. So let's just set that to none again. Next up, we have the first-person body root motion. So this is capturing the root motion from your character animations. You can see on the animator here, we have this apply root motion handled by script. Normally that's a checkbox that you can check on or off. So this is catching that root motion kind of position offset and rotation offset, and it's sending it to the motion controller on the root of the character. This allows the motion graph and its behaviors or its states to actually control how much of that root motion makes its way into your character movement and add things like multipliers and damping to that. Next up, we have Procedural Spine Aim Matcher. So this takes the yaw transform, so the actual, essentially the rotation of the body itself, the heading of the body itself, and then the aim transform, which is kind of the final result of your aiming. So that includes your camera, yaw, and pitch compared to this. And what it does is it takes the difference between the two as a rotation, and it applies that to the different bones up the spine using these sliders here, these multipliers. So for example, we have the base of the spine, the middle of the spine, and then the upper bone of the spine. And we just want to say we want to apply that rotation difference, this amount to that one, this amount to that one, and slightly more to that. Usually you wouldn't want to go above 1 for the total here, but you just want to experiment and get the effect that looks the nicest, essentially. Now, underneath that, we have a section called leaning. Now, this has been a little bit shoehorned in, but essentially the way this works is by applying a lean rotation up the same spine bones and things like that. So it kind of made the most sense to fit it in here. The name doesn't really kind of make as much sense with this in here, but it wouldn't have worked me putting it anywhere else. So settings-wise here, you have a left lean and a right lean. The reason these are different is because with the first-person body, your weapon will be positioned off to one side. So it might well be that leaning right means you're getting a lot of clearance around corners, whereas leaning left means you're barely moving the weapon at all past the corner and you just can't shoot around it. So you sometimes want a slightly larger rotation on the left. And then we have these same sliders that say we want this rotation, this amount on the bottom of the spine, this amount on the middle, this amount on the top, just as above. But we also have a counter lean here. So this is applied to the head and the neck so that it tilts your head and stuff back up again. And you don't end up with a big kind of overextension of the head. So yeah, that's that. The only other one on here is the death animation. So this is just a component that attaches to the health manager on the root, detects when the character dies, and then just sends this, I think it's a trigger parameter to the animator controller. So you can form a death animation. Now you could add a separate system to do things like ragdolls when you die, or to do different animations based on your direction. It's just a very simple one that's out of the box right now. More might come later on. And yeah, that's everything in the character hierarchy. So just to quickly recap, we have got a yaw transform here added to the character, which handles separating out the different time steps and the steering system. Parented to that, we have the actual character model, which has various components for leg IK, arm IK, root motion, and then bending the spine and things like that. We have the upper body here, which has a number of the NeoFPS systems. So that has the yaw, the aim pitch, it has spring animations, it has the item root, which is where your weapons are parented. And these are all 0 transformed to this object here, which is matched to an object in the character spine, this item matcher here. So the position here matches this. And then underneath that, we have camera constraints, under which we have the player camera, and this is matched to the camera proxy on the character itself. On the root of the character, we just have these extra animator and upper body settings here, and we have the steering on the aim controller. And that's it. That's the main difference from a standard NeoFPS character. So let's quickly have a look at the weapons that are required to tie into this and make the arm IK work. So in this Feature Demos first-person body folder, we also have a subfolder called Weapons here. So if I was to open up the firearm, then this is essentially just a slightly cut-down version of the demo facility firearm with a couple of extra bits and bobs added. So there's two main changes that need to be made. The first one, as we mentioned previously, is that we match the camera position to the character's head bone. So what this means is that the traditional weapon move aimer or head move aimer modules from the firearms that we use to procedurally aim down sights aren't going to work properly because the camera that we want to align to is moving completely separately to the transform that the weapons are parented to themselves. Instead, we have to switch over to this one here, which is this camera constraints aimer. So all of the settings within here are exactly the same as the weapon move aimer. There's no different in its setup. It's just a different component. And all this does is it detects the camera constraints on the character, and it just goes, hey, here's a higher priority constraint than the head bone when you aim down sights. So you hit aim, and the camera goes, oh, I'll blend into this new bone, follows the weapon. So this, where is it? Aim holotech. Come on, show me. Show me. There's this object here, which is looking directly down the sight. So the camera will blend to that position and that rotation. And then when you remove the aim down sights, that constraint will be removed and the camera will blend back to the head bone. So that's the main one there. And the other one is right down at the bottom here. We have this wieldable item kinematics. So this is a bit of a big looking component, but it's actually pretty simple. We point at the animator on the firearm. This should auto-populate when you chuck the component on your weapon. We then say which hands do we want to match. So we can have none, left, right, or both. And do we want to match the fingers? So we want to rotate the fingers on the character to match the fingers on here. And then we have the choice of, does this weapon use a generic or a humanoid rig? Most of the time I would expect you're going to be using a generic rig, in which case you need to say that this object here represents the left hand bone. These objects here are the different finger bones. So we do have animated arms on this weapon, but the main difference is that I've removed the skinned mesh that used to be on the object here. So there is no skin mesh anymore, but the skeleton that drove the animations is still here. We still have the different finger bones and whatnot. So if we're looking back at this again. So you need to go down, you need to select all the different bones. So proximal, intermediate, distal, so that is like the base of the finger, the middle of the finger, and the tip of the finger. And apply them for both the hands. If you're using a humanoid rig on your weapon, then all of that disappears because the avatar has all of that information in it, and this component can just grab it all from there. But back to generic, and you've got to specify it yourself. And the other thing that's quite important here is this offsets. So what you will tend to find is that your animated hands on the weapon don't match the animated hands on the character. They might be a little bit out position-wise, or they might be using completely different axes for the different rotations. So what you can do is you can click this button here, Create Offsets Asset, and this will create an asset right next to your prefab in your project view with the same name, and it will just have offsets applied to the end of the name. In this case, I have renamed this because all of my weapons have the same hand setup. So I'm just sharing the same offsets across all of the different demo weapons here. So you can create them per weapon, or you can share. It's absolutely fine. But the awesome thing here is run the game to edit hand and finger bone offsets according to this little info. So if we were to actually hit play and drop out of the prefab, and we find the full body character in the scene here, and there's the inventory, the item route where the weapons are stored. So I'll just expand that out. Here's that assault rifle. And now this is that wieldable item in kinematics that we were just looking at, but now you can see it's got all of these different options down here. So we can offset the fingers. In this case, they all match up. But let's actually go to the scene view and find this dude and zoom in. Right, that'll do. So let's look at the left hand actually. So we can, for example, look at the middle finger here and the proximal. So we can rotate this, and that looks incredibly painful. That too. Boom. So we can use that to say this is the rotation that we want to match. Now, because this is a little bit fiddly to do, we also have these buttons here, which is copy and paste. And so on and so forth. If all of your bones are using similar rotations, you can do that. So I'll just reset those back to 0. And then the left hand position, offset, whatever. So the rotations here for the different hand to match that up. Position offset. Whoop. Yeah, you got to be careful with that one. Control drag gives you a little bit finer placement options, but you might be better off typing that in because you're talking very small distances. Yeah, and that lets you match up your character's hands to your hands that are animated on the weapon. The good thing about this is that as soon as you drop out of play mode, so let's just switch that off so they're both off. If you remember when we started, this one was on for some reason, so if I just hit stop now, and we find the offsets, which is this asset here, yeah, they're switched off again. So it does transfer the information that you set at runtime back into edit mode on the offsets file. Okay, and then the final thing, the only other thing that we want to look at here is this animator location on the firearm itself. So here's the firearm assault rifle. On the root of it, we have the modular firearm component. The same would go for the melee weapon component, the thrown weapon component, or the wieldable tools component. Each of these has a section for animation, and each of these has a drop-down that says, where's the animator location? And this lets you say, we're only interested in the animator attached to the weapon. We want the animators that are attached to the weapon and the character. There's multiple attached to the weapon, multiple attached and the character, or just the character animator. So this means that each of the different modules, the different firearm modules on this weapon, when they send, say for example, the raise animation trigger or the lower animation trigger, they won't just send it to this animator, they'll send it to all of the ones that are found based on these rules here. Now in this case, we're entirely using IK. So if we just hit play again, then all of the hand animation here as we reload and things like that, you can see in the view in the top left, all of the different hand animations are entirely on the weapon and are entirely driven by IK for the character. So the hands that we're seeing are the character's hands, but they're just matched to the position of the bones on the weapon themselves. In certain situations, like the split rig that we'll look at later, or in multiplayer, for example, you might want to also send animations to the character so that they can be synced over the network, or so that they can just sync up separate arms to a separate weapon. In which case, you would set that property, that animator location, to point at one of the character ones as well. So, anyway, that's the full body character and everything that you need to get that working. Hopefully that was useful. Hopefully that made sense. Next video, we'll take a look at the legs and torso character. So, see you in the next one.